So we've been working on the idea, of the xy plane, Cartesian coordinates, it's called. What we want to do is draw Mr. Teddy Bear here. That would take a lot of work if you were just going to string together a bunch of turtle commands to do it. However, if you have a nice draw circle function where you can specify the position on the screen and you can specify the color and stuff like that, that makes it a lot easier. So here we have a dot on our Cartesian coordinates. Since we put x first and then y, what is the position of this dot? It is at coordinates what? Wake up, guys. 10, 30. So fill in your Word document. That's 10 there on the x position, 30 there. Now, in this particular code that I'm giving you, whenever we specify position of the circle, we are specifying the rightmost edge of it. So you might think it'd be cool to be able to specify the middle position of it, and I wouldn't disagree with you, but the way I wrote it is we specify the leftmost edge of it. So what is the position of this circle? What is its xy position if we measure from the marked dot? Yeah, it's 40, 20. So, I'm only hearing one person answer, I think. This is kind of distressing me. We know how to do this, right? 10, 20, 30, 40, and you just don't feel like talking. And then going up is 20. So the radius is half the width of the circle, half the diameter of the circle. What does the radius of this circle look like? Well, how wide is the circle? Pretty much. It goes from 40 to 10. That means it's 30 wide, so the radius of it is 15. And I do understand not wanting to talk is like when your kid's watching Dora the Explorer and she's sitting there waiting for you to say something back to the TV, but I'm not a TV. Go ahead and say stuff back to me. So, tackle the bear. The first we'll do a simplified version. We're going to do just a few of these pieces. Maybe not even that many. We'll see. We'll see. And then I'm going to let you do the rest of them to finish the class, and then I'm going to give you a different shape, a tortoise, that I want y'all to do at home using the same library. So, the first three pieces we want to do are the ears and the head. I know I also have the eyes there. I guess we could add 2 lines at a table, but we're going to do the ears and the head. And if we do them in this order, the ears will appear behind the head, rather than on top of the head. So if we slap one ear down, we slap another ear down, and then we do the head is going to cover that part of the ears, and that's the way that I think it looks good. So what is the x and the y coordinates from that position of ear 1? What does that look like to you? It's not on an even black line, so it's harder to tell. Anybody have any opinions? Is it 24, 25? 25. Let's go with 24. That's its x position. What's his y position? Oh, that one's easy. His y position, yeah, I was looking at the I. Sorry, you're right. It's like either 51 or 52. We can go with 52. The second ear is at the same height, so we could give it a y of 52 as well, just to fill that in. But he's got a different x coordinate. What does that look like? That looks like it's at... What am I doing? I'm doing the I again. I need to take those lines off. Okay, yeah, it looks like it's at maybe 76. We can go with that? Alrighty. And the head itself. Oh, we need to go back and get the radiuses of the ears, but we'll do that in a minute. The head is at position 70, 30 in my opinion. 70, 30. So what is the radius of this ear? It's not exact. It looks like it's going from, I don't know, 3 out to, what did we say, 24. So that 24 minus 3 is 21. We need something that's half of 21 for the radius, maybe 10, maybe 11. And I'm just going to kind of eyeball it this time with my fingers. The radius of that one, a little less than 10 actually, but it'll be okay. I may change this to 10. I don't care. And the head. What did we decide his radius was? We haven't. That one's easy, so I'm not going to do it for you. What's his radius of his head look like? 30. 30. Yeah. So we have enough here to get our drawing going if we have the code that's going to draw the circles. So on the next page we see some code. It looks kind of similar to what we've used before. It imports a turtle. It has a relocate function so that we can just say go from here to here. Lifts the pin, moves, goes back down, and then it draws a circle. The circle function that we're writing takes 4 parameters. One is the x position, that dot. One is the y position, that dot. One's the radius, and one's the color that you want it to be filled with. So, just copy and paste the whole shebang. Don't type it in individually. That'd take 10 minutes and there would be typos and stuff. So you ought to be able to go into that box, do a Control A. Whoops, that didn't work. Control A to highlight it all, or however you like to highlight stuff. Do a copy, open up idle. I'm going to call this one bear 1 in case we draw a second bear or something like that. And I'm just going to paste what I have in there. Now when I run this, it doesn't do what we want. It draws the crosshairs and it draws a circle. That's just to kind of make sure that the code's working. So copy and paste that code. That proves that it's working. And then scroll down here to the bottom where it says #main. We see it calling the circle function once, and it's drawing a light blue circle at a specific pair of coordinates. We want to modify this to draw the 3 circles that we've taken note of in our document. So, I'm going to comment that one out. I could just delete it. There's really no reason to leave the blue one. And I want to add 3 circles that draw it in this colors and this radius. And I think I'll put comments on them as I draw them. But anyways, circle, the x coordinate of the first year is 24. At least I decided it was on mine. 52 with a radius of 10 and a color of tan. Got to put tan in quotes. If you don't want to make it tan, that's okay. If you're interested in the colors that can be drawn in the with the turtle, go to Google, type in TK colors space Python. And you'll get a page with a whole bunch of colors. that you can pick for them. This is useful because when you choose brown for the inside colors of his ears, it looks really lousy. You're going to want to pick a different color other than brown. Yeah, bless you very much. So here we go. That's one circle. I'm just going to copy and paste that line so I don't have to keep typing it in. That's one circle. The next one is at 7652. The third one, the larger one. So I'm going to put comments. This is ear 1. That's ear 2. That's head. The head is at completely different coordinates. Alrighty, kind of drew our misshapen Mickey Mouse looking thing over there. That's not super duper impressive. I made the crosshairs function so that we could just tell where the center of the screen was, kind of exactly. And what do we notice about the bear? Well, he's not centered. And he's awfully small. So what we want to do is we want to blow him up, make him larger, and we want to push them over into the center of the screen. Now, yeah, we could try changing all these coordinates. You know, we could get a different sheet of graph paper, draw them again, write down different coordinates, plug them in here. The better thing to do is to modify the circle function so that it automatically shifts it to where it needs to be and scales it. So what we're going to want to do is shift it. We want to move it to the left and down so that it'll be right in the center. So what is that going to do to our x coordinates? When we move him over that way, are we increasing the x or are we decreasing it? Yeah, we're decreasing it. Same for the y. We're going to be pulling it down into the negative part. So we're going to be decreasing it. So back on the next page of the Word doc, shifting the coordinates. Our bear is tiny. It's in the wrong place. We need to learn about shifting and scaling. So to shift it, here's a shape with a radius of about 10, kind of like the ones we're dealing with. And I chose these values because they match pretty much our drawing. They're going to wind up shifting it into the right place. If they didn't, you would just modify the shift values that we're going to come up with until it wound up in the right place. But anyways, so we have two circles. Identical radiuses, we just want to push this circle down and to the left until it is focused on coordinate 0, 0, which is going to be the center of our page, of our screen. So we need to modify his x coordinates. We need to modify his y coordinates. So we're just going to take the difference between the two. So C1's x coordinate is, counting over, 50, and his y coordinate is 30. So 50 and 30. Circle 2's x coordinate is at 10 with a y value of 0. And so how far did C1, how far did it have to go to the left to be there? It's the difference of the two. 50 minus 10 is 40. We had to shift 40 pixels to move it over here. And to move it down, 30 minus 0 is 30 pixels. So you're just taking what's known as the delta, the difference between those two. Those are going to be our shift values. So let's go and modify our code to do some shifting. Go back into our bear code. Now I don't want to shift everything, down here. I don't want to subtract numbers from all this stuff. I want to have it happen automatically. So I'm going to do it in the circle code. So before we call relocate, we need to have two variables, a shift x and a shift y variable. Shift x we decided was, let me look, 40. So shift x equals 40. That's a new line. Shift y is equal to 30. That's a new line. Now we need to modify x and y. So x equals x minus 40, or I could just do x minus equals 40. No, not 40. I have a variable called shift x. I may as well use it. And then y is equal to y minus shift y. Why don't we need to do the same stuff in this relocate function? Because relocate is called by circle. So as long as we change the coordinates before we call relocate, we're good. Alrighty, there we go. That looks kind of menacing, doesn't it? Poor bear, it's got crosshairs trained on it. But anyways. Now we need to shift it to blow it up. Having a bear the size of a quarter on your screen is not nearly as impressive as it could be. So scaling is multiplying. Shifting is adding and subtracting something to get it into the right position on your Cartesian system. Scaling is multiplying the values. If you multiply it by a large value, it gets bigger. If you multiply it by a small value, a percentage, it shrinks. If you multiplied it by a negative value, it would flip it. I can't think like that. Anyways, so here we have a line. And this thing, we could say that its x-coordinate is 20 and its y-coordinate is 20. If we go from that side right there. But we want it blown up to be twice as large so that its x-coordinate is 40 and its y-coordinate is 40. So here's our original line in green. And here's our new line. So we're going to scale the same way left and right. Excuse me, left to right and up to down. If you use different scaling factors, you can make it wider than it was tall. But I don't see any reason to do that. We just want the whole thing to increase equally. So we could just do one set of coordinates. We don't need to do both the y and the x. We can just go with the x. So B2, that coordinate is, and what does this green represent? That represents the area of our original page here. Let's go back up here. So B2 is at 40, 40, so I'm just going to say that his x-coordinate is 40. B1's at 20, and to calculate the scaling factor, you divide the larger one by the smaller one. 40 divided by 20, 2. An interesting thing to note is that when we scale by 2, it actually makes it 4 times as large. Why is that? Because pretend this was a square here. If you multiply it by 2 that way, and you multiply it by 2 that way, it actually holds 4 times as many as the original square. Alrighty, so let's go and add a scale factor. Go back to your code, and where we have shift x and shift y, let's add 2 more variables. So above our relocate, let's do scale is equal to 2. So that's a new line. And when I hit tab, it keeps pulling up the autocomplete. And then we're going to do x is equal to x times scale, and y is equal to y times scale. And like I said, we could do a different factor on each one, but we just want to preserve, you know. If you had one of those TV screens that you need to switch between modes so that it fills the picture or it puts it in a smaller rectangle in the middle, you would have different x and y factors. In this case, a single scaling factor is good enough. All right, let's run it and see if our bear is now both in the center and larger. Yeah, that's not too hot. There was one more thing I needed to scale besides the x and y position, and what might that be?
The radius.
Yeah, we have to scale the radius as well, or else, you know, we're moving things around, but the circles are still their own small size. So one last line under this scale stuff. Radius is equal to radius times scale. And as always, you don't have to put the hashtags. They're just visual markers. There we go. He's bigger. But we want to make him bigger still. Keep playing with that scale number until you get it to a value you like. You know, try 4, 6, 10, 20, whatever. Just experiment a little bit with it. Having done this assignment before, I have a value that I like, but you get to pick your own. Alrighty. Did y'all come up with a good number? Anybody have a value that they like? 5, 7? Yeah, what? 10's a nice whole number, but it's a little too large. I'm going to make the scale of it 10. Run it. Big bear. You know what? We need to change his speed. But anyways, okay, yeah. So 7 or 8, something like that. It could even be a partial value, 7.5. I'm going to leave mine 7. Alrighty. Here is the completed bear. You can see he's got a lot more points than just the 3 that we've already drawn. He's got inner ears. Sienna, in my opinion, is a better color than brown. Go ahead and try brown and you'll agree with me that it's a horrible color. A nose, 2 eyes, the blue irises, and the mouth. So, just to get things rolling, I think I'll do the inner ears with you, and then I'm going to let you work on the rest of them. And then if you look at the last page of this thing, you'll see, whoops, where'd he go? Okay, I'm going to have to upload the homework assignment separately. It's to draw a tortoise. I'll bring up a picture of it in a minute. So I'm going to scroll back down to the bottom. I want to draw these inner ears after the outer ears so that they appear on top. They're not hidden by them, but before the head. So that's just my personal take on it. I'm going to put them underneath it and then just demonstrate that that's wrong. So this is going to be inner ear 1. And to me, his coordinates look like, I don't know, 2251. And the radius has to be smaller than the outer ear. 8 looks good to me. And if you make it brown, you're going to see how bad brown looks. Looks reddish to me. Looks kind of like dried blood. I don't know. So going back to that TK color chart that I told you up to Google, a different brown that to me looks better is one called sienna. Or chocolate. I'm going to go with chocolate this time. If you want to make yours a Grateful Dead bear with all sorts of psychedelic colors, that's fine with me. All right. I can live with that, I think. So, oh, I forgot to demonstrate though. Or forgot to leave it open to make my comment. The order of these things is important. Maybe I think it looks pretty good having the inner ear not covered by the head. I might leave them in this order. But the original drawing on the front page or whatever of our Word doc, like that, showed it behind it. I am going to change it to sienna. So I need another inner ear. I'm just going to copy and paste all that, but change the x coordinate. And then I'm going to leave the rest to you. Wander around, help out. This one looks like it's at about 74 to me. But the y coordinate should be the same because, you know, it's on the same level. It's the same height, and the radius ought to be the same. So I'm just going to change that ear to, what did I say, 74, and leave the rest of it. Oh, and I'm also going to increase the speed. I'm tired of him drawing so slow. So right above the crosshairs comment, I'm going to do t.speed 0. That's the fastest he'll go. So this is a new line of code. I'm going to say warp speed. Unfortunately, it's not really that fast, but I think those ears could stand to go up a little bit more. I don't think 51's a good value. Anybody come up with a different opinion on the Y value of his ears?
It looks good when you have it underneath the head, but not over.
Yeah, I'll do that. I'm going to move the head underneath those two ears, so it'll draw it on top of it. And I still want to bump it up a little bit.
25.
I'm going to just try 52 so that they'll be at the same height as the outer ears. Yeah, okay, I'm happy with that. it's just every time you break it.
It was a long time.
Oh, okay. Well, that's not fair. So the Dropbox for this is already made. Go ahead and upload the bear to the Dropbox when you get it done. I'm going to make the Dropbox for the homework now. And I'm going to show you a picture of it.
So we have to make the eyes and stuff blue green.
Yeah, go ahead and fill in the whole bear. I don't care what colors you make them. I don't care if you make them cross-eyed or, you know, whatever. But just finish your drawing. So the homework is going to be to draw a turtle, or tortoise. What could be more appropriate with the turtle library than to draw this guy? I don't care what colors you make them. If you wanted to modify your code so that you could fill with different colors, you could do that. Let me show you a place in the code where you could change that and you could wrestle with it if you really wanted to. But suppose I wanted to be able to specify a different color for the inner eye than for the outer, or if I wanted them all to be in a black outline. This line here, t.color, the first one is the color of the line. The second one is the color of the fill. So if I wanted to make it look a little more like a coloring book, I could make the lines always be black. I might want to set the thickness. But anyways, maybe you can see the black lines around it now. If you like that look, that's totally fine. What I modified is the t.color. You could even make that a parameter that you passed into the function. Call them color 1, call them color 2, fill them in there. That's if you feel like exploring. So into the Dropbox, I'd like for you to put the Word document that you filled your coordinates in, as well as the code for the bear. And then just so it's easy to find the code for the bear so that when you want to work on it some more, you can change it into the turtle, the tortoise. Put it in the homework Dropbox as well that I'm about to make.